Okay, now I'm recording now. Yeah. By the way, Louis is not joining. Edison. Louis 没有，今天没有 join。
我不知道，我问了哈。
Okay, never mind. You just continue. Okay. Okay, now this is the exercise that I shared in the group last week. Later, I will send it again, okay, because we have new students here, so you can just download and try out. Okay, so for the previous lesson, 我们学了 momentum, impulse, and now we are at just want to enter force, right? So force, impulsive force, and then gravity later, right? So now this one, let's look at question number 5. We are at momentum and impulse right now, okay? Momentum and impulse. And then after we discuss these two questions, then I will teach a new chapter, which is the force. We'll continue the lecture, all right? So now, question 5. I want to talk about question 5, okay? Now, water issues horizontally from a hose of cross-sectional area. Now, let's draw it out. Let's draw it out, easier to see, okay? So this is your hose. Okay, now cross-sectional area is the area of the opening here, meaning that if you have a hose and then imagine you cut it at the center, okay, 你把它切一半，然后你看它的旁边那边，那个就是我们叫 cross-sectional area. Okay, that one is a cross-section. So in this case is this one, the shaded region. So 5 cm2. Okay, now water issues at a speed of 10 meter per second. So inside, water is moving at 10 meter per second. Now, the water hits a vertical wall without rebounding. So in front, there is a wall here. So what is happened is there is a jet of water coming out, right? Jet of water coming out and shoots on the wall. Okay, now find the magnitude of the force acting on the wall, meaning that it wants to find what is the force that is applied by the jet water on the wall. Okay, so same, a moving water has momentum because water has mass and is moving, so it has momentum. Okay, now what happened? Now let's look at the concept before we do the question. Let's look at the concept behind it. When a jet of water, okay, shoots out from the water hose and shoots on the wall, it will exert a force because the momentum of the water will transfer to the wall. All right, so same as like a ball is thrown at your face. Imagine a ball is thrown at your face. It's very pain, right? So you feel the momentum of the ball is transferring to your face, and then you feel the force. You feel the force is very pain, right? Same thing. Okay, why you feel the force? Because the momentum of the ball transferred to your face, meaning that after the ball hits your face and then it falls down to the ground, right? It falls down to the ground. Now the momentum of the ball is now less than the momentum before it hits you, because some of the momentum has been transferred to your face. Okay, so you feel the force. So the point is when there is a change of momentum, there is a force. Okay, and the force depends on how fast is the change of momentum. So we learn about this equation. I write out this equation. Impulse Ft. Yeah, the pen starts. Okay, my pen is not working. Give me a minute. Sorry, give me a minute. Okay, yeah, it's working now. Okay, the formula, what is the formula for impulse and momentum? So we learn about impulse, which is Ft, force times time, equals to the change of momentum, mv minus mu. Okay, so whenever there is a change of momentum, there is a force acting. Now back to this question. So this question is asking you to find what is the magnitude of the force here acting on the wall. Okay, because you have a jet of water shoots out. So how do we find that? Okay, we use this formula. Okay, Ft equals to mv minus mu. Now to find the force, we need to know what is the change of momentum, meaning that we need to find out what is the mass of the water, what is the final velocity of water, and what is the initial velocity of the water jet, right? So first, let's talk about the final velocity. Now, when the water jet hits the wall, you see this sentence says here, the water hits a vertical wall without rebounding. Without rebounding means that the moment it hits the wall, it stops. It won't reflect it back. It won't be reflected back. Okay, it won't rebound, right? Meaning that the final velocity is 0. All right. So initial velocity is shooting out at 10 meters per second. This is u. U equals to 10 meters per second. So what is the final velocity? V equals to 0 because the water does not rebound. Okay, now we got U and V. Now how do we find the mass of water? Mass of water, see, 它有给你 density 是吗? Take the density of water as 100 kg m 减3. There is density, so we use the equation of density. Because in this question, the mass is not directly given to you. All right, so we use density equals to mass divided by volume. Okay, so to find mass, we need use density times volume. This is how we find mass. Okay, so this question is a little bit tricky, but a little bit long, right? So mass is density times volume. Now, since I already know the density of water is given, right? So how do I find the volume of water? How do I find the volume of water? Okay, this is where it gets challenging here. Now, let's find out what is the volume of water hitting the wall in 1 second. What is the volume of water hitting the wall in 1 second? Let's take the velocity of the water. The water is traveling at 10 meters per second. Okay, 10 meters per second, meaning that every second, the water is coming out 10 meters from the hose. Okay, so if I draw again, this is the hose. And enlarge it. This is the hose. And this is the water. I use dotted line, okay, representing the water. Okay, so at 1 second, the water is coming out 10 meters. Right? So how do we calculate the volume of water that is coming out in 1 second? You got the length, this one, and you got the cross-sectional area, this one, area here, right? So how do you calculate the volume in this 1 second? Okay, so you just use the area times the length, which is 10 m. That is the volume of water coming out in 1 second. Okay, meaning that the volume of water hitting the wall in 1 second is also equal to 10 times 8. Right? Now, let me put it this way. Yeah, very laggy here. Okay, so I write volume of water per second equals to 10 times the cross-sectional area. Okay, so 10 times cross-sectional area. Just now we worked out, right? 10 times A. So 10 times A is 10 times 5 times 10 to the power of -4. This one is just the cross-sectional area. Okay, this one is actually 5 cm square. Okay, you change to meter square, so it's 5 times 10 to the power of -4 meter square. Okay, so this is the area. So here, calculate, you will get 5 times 10 power of -3 meter cube. Okay, so 5乘10 power of 减3, this is the volume of water coming out from the hose in 1 second. Okay, so if you want to calculate the mass of the water, okay, the mass of water hitting the wall, then you use the density equation. Mass equals to density times the volume. So density is 1000 times 5乘10减3. So that's how you calculate the mass of water that is hitting the wall in 1 second. Okay, so this one you get what? 5 kg. 5 kg. So now you know the mass is 5 kg. Okay, so you got everything already. You got everything already. Now you can just calculate the force. How do you calculate the force? Okay, now Ft, I write it on the left-hand side here. Left-hand side here. So Ft equals to mv minus mu. Okay, now I already know v is 0. So mv is 0. So left Ft equals to mu, negative mu, sorry, negative mu. Okay, now equals to negative mass is 5 kg, initial velocity is 10. Okay, Ft, now what is the value for time t? Because now you are calculating everything in 1 second, right? You are calculating what the volume of water in 1 second, you are calculating the mass in 1 second, so your time for this formula, you use 1 second. We are only considering 1 second. Okay, so this one you simplify, F equals to minus 50 Newton. This is the force. Why is it minus? Why the force is minus? This minus tells me that because force is a vector quantity, meaning that force has direction. Positive is acting to the right, negative is acting to the left. Okay, so when the jet, back to this diagram, look at this diagram, when the jet of water hits the wall, so the force exerted is opposite to it, is acting to the left. Okay, so the force is acting to the left, which is why it is negative. It's just the sign, just saying you the direction. Okay, the force is acting on it. That's how we label the force. We always label the force pointing out of the surface. In this case, the surface is the wall, right? We label the force pointing out of the surface. So here, okay, so 50 and the answer is 50 Newton. Here, you can check our solution here. All right. Now, of course, this I'm just giving you extra this question because I see because your teacher sometimes they will distribute this 从真 I mean the UEC 的练习. Yeah, sometimes they will ask this UEC 的练习. They have been asking in the few past years. In the I think your senior lah. The past years they have been giving all these exercises. So this is one of it. It's very quality questions. So I'm not sure if they are going to ask in exam. Okay, but it's better to be prepared. Okay, so you have question 5, 6, question 5, 6, 7, 8, 9, 10, 全部都是一样款. So I'm just showing you question 5. Okay, and then you apply the same for question 6 all the way to 10. Okay, now I'm going to send this again in the group. Okay, again for the new student, you can just download and try it out. Okay, but of course, you can slowly catch up because you missed the previous lecture. It's okay. All right. Okay, the was I sent. Okay. Okay. Now let's continue. Let's continue. All right. Done with this question. If you have any more problem with the exercise last week, then let me know. Just let me know. After I finish the chapters for today, then we will discuss the exercise. If you have any problem, all right. Now, okay, let me get my whiteboard. Okay, force. Now, simple terms is just push and pull. All right. Now, push and pull. Now, force. Let me take you a step back into the basics. Okay. Sometimes we human complicate stuff so much. So it's sometimes it's okay to go back to basics and learn about it because basics is all the fundamental things is the most important. Okay, let's take a few back. Okay, before we go into the real physics. Yes. Now, force is all the actions we perform in our day-to-day lives. Okay, all the actions we perform in our daily lives requires a force. Okay, such as opening a door, cycling, lifting. You go to the gym, you need force, and even when your friend pushes you, okay, you experience a force. Okay, when you are pushed. Now, what really is a force? Can somebody tell me what really is a force? If I want you to describe it, let's consider. Let's consider a stationary ball on the ground. Stationary means at rest. Okay. Now, suppose a player A wants to pass the ball to his teammate. Okay, this is player A. Now he wants to pass the ball to his teammate. Excuse my drawing, very terrible. Okay, teammate B. Now, person A wants to pass the ball to his teammate. Now, he needs to move the ball in the direction of his teammate, right? So what do? He kicks the ball, right? He kicks the ball. Then when he kicks the ball, we say that he applied a force on the ball. To the right, force. Okay, so the kick here is nothing but a push force applied. Okay, I repeat, the kick here is nothing but a push force applied. Now consider another scenario where you want to move a desk from point A to point B. Okay, now a person wants to move the desk from point A to point B. Now, how will he do that? You don't say, right? You don't say. He will push the desk, right? Just push the desk from point A to point B. Right now, in this case, we say that the person applied a force on the desk in order to shift it. Okay, so this force applied is nothing but a push applied. Right? Now, similarly, if you pick up a pen from a table, you are also applying a force on the pen. Okay, now this force is called the lifting. Now, in this case, in other words, I can also say that you are pulling the pen upwards. Notice that the word I use is always either push or pull, right? I'm pulling the pen upward, right? Other examples, just like you hitting the hammer on a nail, you're applying a force on the nail, stopping a moving ball, or opening a drawer or playing a guitar. All of this, moving a piece on the chessboard, all of this requires force. Okay, so these are just a handful of simply too many actions that we can perform on the object. Now, so if you take all of this explanation, now if you summarize it to describe, use a shortest sentence to describe what is force. So force is just push and pull. Okay, so we categorize all these action into two basic ones. It's just pushing and pulling. Okay, example, when you are opening the drawer, you are actually pulling the knob, right? When you are stopping kicking a ball, you are pushing the ball. When you are opening the door, you are pushing and pulling the doorknob. When you are lifting a pen, you are pulling it to the upside. It's just push and pull. Okay, now what forces can do, by the way? Forces can do a lot of things, right? You can change the shape of an object. Change the shape of an object. Now notice that force can change the shape. Let's say force of compression on a balloon. Okay, you are holding a deflated balloon, and then you press it. You're pressing a balloon between your hands. Okay, so you're applying a force to compress the balloon, so the shape changes. Same with a rubber band. You're stretching a rubber band, stretching it out. Okay, and then the shape of the rubber band changes, right? And then you let go, it snaps back. It snaps back, and the shape retains. Okay, and the shape return to its original shape, right? So other than changing the shape of an object, force can also change the size of an object, just like pulling a spring. When you pull the spring on both ends, okay, it elongates, right? It elongates, and then the size changes, expand. Okay, this one is we call deformation, which we will learn later, right? Deformation. Okay, and what else? It can change the what else? Direction. Change the direction of a moving object. Let's say you pass you kick the ball to your friend, you pass the ball, pass it around. So in a soccer team, everybody, all the member of the team is constantly changing the direction of the ball, right? Now, force can also change the speed of a moving object. Meaning that initially an object is moving, I can apply an additional force or external force to accelerate it, okay, to push it faster. Okay, just like pedaling, you are cycling, you're pedaling, you pedal faster, and then you increase your thrust. Thrust is a force that is pushing your bicycle forward. Just like driving, you increase, you accelerate, you press on the pedal, you increase the thrust of the car, right? And what else? It can stop a moving object. Stop a moving object, okay, move a stationary object. So I don't really have to go through in so detail. This one is just common sense, right? Common sense. So I'm just reminding you, right? So force, these are all the effects of force, right? Change the shape, change the size, direction, and move it. Okay. And how do we measure force again? How do we measure force? Simple way to measure force, we use a spring balance. Spring balance looks like scale here, and the other end is attached with a hook. Okay, simple device that they use to measure the weight of your luggage. Okay, of course in airport they don't use this, right? They use the weighing machine. This one is just to use for personal use. Okay, personal use. Now, how will you measure the weight using a spring balance? Okay, first you would hang the luggage from the spring scale hook, right? Hang the luggage from. Are you guys sure is okay the voice? I keep experiencing very laggy one when I especially when I sketch. It's so laggy. Hopefully at your end is okay. Okay. Now, yeah, spring balance. So how would I measure the weight? Just hang it, right? Hang it. Now, the moment when you hang it and then you lift it up in air, you lift it up hanging in air. Now, notice that gravitational force is always acting downwards, and that is the weight. Okay, when you lift it up, you apply an external force. Okay, you apply an external force to lift it. So this is called the lift force, and this lift force is balanced by the weight of the object. Okay, so F is equals to W. Okay, so the spring balance, what it measures is actually measuring the weight of the object, but at the same time, you can also measure the force that is applied because they are the same. Okay, so what is shown on the scale is the weight, is actually the weight. Okay, so F equals to W, same. So this is a way to measure, a simple way to measure the force. And how do you measure horizontal force, pulling force? Okay, you have this diagram, right? We all seen this diagram. We have all seen this diagram somewhere. Okay, you attach the spring balance horizontally. Okay, and then you pull it the other end here, you pull it here. Okay, and then the spring balance will read the scale. And another device to measure force is actually using a dynamometer. Okay, dynamometer is basically a device for measuring rotational force. Okay, moment. Okay, rotational force such as engine power. Okay, so for engine power, you need dynamometer because you need to calculate how much torque. Torque is just a rotational force, right? Torque, how much torque is produced by the engine car. Okay, now done with the introduction stuff. Now let's look at this one. So force, let me repeat a bit. Forces, okay? Now let me take you further into an area where there are some element of physics inside. All right. Now let's consider. Oh yeah, by the way, I left 5 minutes here. Okay, everybody，因为我剩下5分钟，它就会自动 kick 我 out，所以我们 log out and log back in. Okay, everybody log out and log back in. I will invite you again, and then we'll continue from there. Okay, so I'm going to end the meeting and invite you back.